friend. My metric number is 14M23F1011. Today I'm going to present about flash flood phenomenon in Malaysia. Okay, come, let's go. First, introduction. These pictures are December 2021 Klang Valley flood affecting Kuala Lumpur and Selangor, leading to 70,000 evacuations. These are the pictures that happened in December 2021 at Klang. Okay, next one is problem background of the flash flood. First, recent flash flood events in Malaysia. December 2021 Klang Valley flood. The location is areas affected included Kuala Lumpur, Selangor and surrounding regions. The impact is one of the worst flash floods in recent history, causing over 70,000 people to be evacuated and inflicting extensive property damage. Because persistent rainfall over several days led to severe water accumulation in urban areas, with water quickly inundating homes, roads, and public spaces. Economic and social costs. The flood led to significant financial losses, disrupting business and costing millions in repairs and lost productivity. Okay, next. The next problem background of the flash flood is causes of flash floods in Malaysia. First, heavy rain. Malaysia gets a lot of rain, especially during monsoon. Too much rain at once can cause floods. Second one, more buildings. Cities are growing fast. Trees and grass are replaced with roads and buildings, so rainwater can't go into the ground. Third one is old drains. Many drains are old and small. They can't handle so much rain, so water overflow, then we will get the floods. Last one is weather changes. The climate is changing, causing more sudden and strong rain, which increases flood risk. Okay, next. The impact of flash flood in Klang Valley is first one, human impact. Human impact is displacement and safety risk. Flash floods often force residents to evacuate their homes, leading to temporary shelter arrangements and significant disruption to daily life. Then December 2021 Klang Valley flood led to over 70,000 evacuations. Next, health risk. Stagnant flood waters can carry pollutants, bacteria and debris, posing health risks such as skin infections, waterborne disease and respiratory issues. Then the psychological impact of losing one's home or belongings combined with the trauma of sudden evacuation can contribute to mental health and challenges in affected communities. Okay, next. Second impact is economic impact, property and infrastructure damage. Flooding causes significant damage to homes, commercial buildings and essential infrastructure such as roads, bridges and power supplies. Repairing and rebuilding can take months and strain financial resources. The Klang Valley flood in 2021 resulted in millions of ringgits in property damage, with businesses losing assets and inventory. Then business and productivity losses. Floods disrupt business operations, forcing temporary closures and interrupting the supply chains. Local economies often experience a downturn, especially small business that lack the resources for quick recovery. Second, many business in flood-prone areas lost due to downtime and the cost of repairs. Then impact of third one is environmental impact. Ecosystem disruption. Flash floods can cause soil erosion, remove vegetation and harm local wildlife, altering natural habitats and ecosystems. Heavy rains and floods can wash away topsoil, reducing the land's fertility and affecting agriculture in nearby rural areas. The fourth one is infrastructure impact. Transportation and utility damage. Roads, highways and railways are often submerged, blocking access and delaying emergency responses. The Klang Valley flood affected major roads, impeding movement across urban areas, and strain on drainage and water systems. That means outdated drainage systems cannot handle heavy rains, leading to overflow, backflow, and further urban flooding. That's all from me. Thank you.
Good morning to Madam Siti Farida binti Juhari. My name is Murali Krishnan and my metric number is 14-23F1800. Lastly, my class name is DAM4A. And in this presentation, I'm going to explain about the engineering management in society. First, we're going to see about the role in engineering in flash flood management. So there are three roles. First role is a risk assessment. The engineers play a crucial role in identifying flood-prone areas and assessing the risk posed by potential flooding. They use with historical data, rainfall patterns, and topographical mapping to pinpoint areas most vulnerable to flash floods. Infrastructure design and development. Engineering engineers design flood-resistant infrastructure to withstand high water level and heavy rainfall. Example include elevated roads, flood-proof buildings, and reinforced drainage systems. The third is innovative solution. By integrating advanced technologies such as GIS, geographical information system, remote sensing, and hydraulical models, engineers improve flood prediction accuracy and design tailored solutions for the at risk areas. Now we're going to see about the examples of engineering intervention in a flood mitigation. So we got two. First is a flood resistant building design. Engineers develop building designs that minimize water damage, such as raised foundation, waterproofing, and stormwater diversion system. Second, drainage water retention system. Modern drainage system, larger capacities, and green infrastructure element like retention ponds, rain gardens, and permeable pavements help absorb excess water and reduce runoff. Now we're going to see about the strategic risk assessment and mitigation. So first, we're going to see about the risk analysis and assessment techniques. We got three. First, predictive modeling. Engineers utilize predictive models to simulate flood scenarios and identify high risk areas. These models are based on data like rainfall, topography, and drainage pattern. Second, GIS or Geographical Information System. This technology may help map flood-prone areas by analyzing geographical and environmental data. And also, this technology support engineers in visualizing patterns and identifying flood zones. Third, hydraulic studies. Engineers conduct hydraulic studies that analyze how water flows and accumulates in urban and natural landscape. Second, we're going to see about the mitigation plans and engineering solution. So there are two: flood barriers and retaining walls. Physical barriers such as leaves and embankments and retaining walls help contain floodwaters and prevent them from entering critical areas. Second, improved drainage system like upgrading urban drainage infrastructure is essential for handling higher volume of water, and engineer design modern drainage channels and retains ponds. So now I'm going to talk about the sustainable engineering solution. There are two solutions. First is flood resistant infrastructure, and green. Second is a green, eco-friendly, and sustainable drainage system. So now we're going to see about the flood resistant infrastructure. In that, we got the durable building materials. Engineers are now designing structure with flood-resistant materials such as concrete and metal alloys that can withstand prolonged exposure to water without structural degradation. elevated structure in flood-prone areas, buildings and critical infrastructure are often elevated to reduce risk of water damage. Third, the flood walls and barriers. Installing the flood walls around vulnerable facilities or neighborhoods help help block and redirect the water away from the critical infrastructure. Now we're going to see about the second solution, which is eco-friendly and sustainable drainage system. So we got two. First is sustainable urban drainage system, or we can call as SUDS. This system manages rainfall sustainably by mimicking natural water absorption. And then second is a retention ponds and salts. These natural or constructed depressions are designed to hold and slowly release water, reducing the strain on the drainage system. Okay, and then we're going to see about the community engagement. We got two engagement that we can see. First is the public participation in planning. From this, people involving resistance ensure solution or trailer to community needs. Second, the awareness and education campaigns. These campaigns are educating the peoples, help them prepare and respond effectively during the floods. And now we're going to see about the overcoming challenge. So we got two challenges that we can overcome. First, resource allocation and budgeting. Effective management ensure limit funds used for higher impact solution. And the second is interagency collaboration. Coordinating with the various bodies improve response speed and project success. Lastly, we're going to see about the long-term planning. So there are two type of long-term planning. So first, sustainable infrastructure development. In that, in this development, building eco-friendly and resilient system prevents future flood damage. And second is policy integration and monitoring. This is including the flood strategies in long-term politics, ensure consistent implementations. Okay, that's all from me. Thank you.
Hello everyone, my name is PAVITRAN. My metric number is 14M23F1023. Okay, I would like to present about professional body involved. There's a two type of professional body involved, which is Board of Engineering Militias, known as BEM, and second is Institute of Engineering Militia, known as IEM. So the Board of Engineering Militia role and mission is the body of engineering practice in Malaysia. Its mission to ensure that engineering project and practice meet high professional and ethical standards. License and regulations. BEM is responsible for licensing engineering and engineering firm which ensure that only qualified professionals handle critical infrastructure project and including flood mitigation and sustainable drainage solutions. Third is setting standard and policy. BEM establishes engineering standard and policies that embodies sustainability, safety, and innovations. Second is research and development. IEM is an advanced and research-oriented body that promotes continuous professional development for engineering in Malaysia. They conduct studies on sustainable engineering practice and advocate for environment-friendly solutions to pressing infrastructure challenges. For promoting best practices, IAM best practice sustainable energy, which is flood management and urban design, and by organizing seminars, workshop, and training section. IAM equip engineering with the latest knowledge and tools for sustainable flood mitigations. And for practice, IAM actually promotes the green and resilient infrastructure, pushing for the adaptation and policy aligned with the Malaysian Green Technology Master Plan. Next, we move on to 4.0, which is sustainable and green engineering approach. There's a two type. One is a natural based solution, and second is sustainable urban drainage system, which known as SUDS. So in nature-based solution, there is a rain garden, small garden, and landscape area designed to capture, which know as mangrove restoration and reforestation, coastal mangrove and urban trees, which absorb excess water and protect against erosions and create barriers. Second is permal pavements, which is traditional concrete permal pavements are allow water to seep through into a ground below. This reduce runoff and license the road and drainage system during rainstorm. Third is bioorientation ponds, which is a rainwater catchment basis on biosolvents. These are designed to temporarily stop and filter runoff water. They allow water to slowly inflate into a ground and reducing the volume of water and enter drainage system. Lastly, we move on to 5.0, which is Malaysian Green Technology Master Plan, which is raising awareness about flash flood risk, warning sign, and safety measure is crucial. Educational program and campaign can inform the resident on action to take before, during, and after flood, such as evacuation routes and safety procedure. Community members can work together, implement small-scale solutions such as building garden, creating sandbag station, and organizing cleanup drivers to keep drainage system clean. Community can advocate for the inclusion of green spaces such like park and wetlands in urban areas to serve as natural flood barriers. Fourth is a program that encourages residents to adopt practice for water conservation, rainwater and harvesting and landscape management support long-term flood relations. Fourth, lastly, is social media platform, which is messaging app and local online group allow community to stay connect during flood situation. And this platform enable information sharing and safety checking and coordinate the response. 5.1, which is innovation and innovation in flood management. Permeable payments. This pavement allow the rainwater to seep through the surface and reducing runoff and decrease the likelihood of water pooling on street and sidewalks. They are commonly used in parking lots, driveways, and walking ways where stormwater drainage is extended. Function made from a material like a porous concrete and alpha and permeable pavements channel water in the ground below, aiding groundwater recharge and minimum surface flooding. Benefits are beyond flood control and reduce urban heat and support environment sustainability by lowering pollution from runoff. Let's move on to conclusion. So the conclusion about flash flood are becoming a bigger problem due to rapid urban growth, outdated infrastructure, and climate change. Cities are increasing at risk, and current drainage systems are designed to handle heavy rainfall, causing flood to happen more often. To tackle this challenge, engineering need to be developed better flood management solution. This include upgrading drainage system, creating green space like permeable pavements and green roof, and using a new technology like smart flood barriers and early warning systems. Collaboration between engineering and city planners or local government is a key to building a stronger flood protection system with climate change making a storm and more intense heat. It's crucial to act now to prevent more damage in the future. In short, flash flood require urgent action, innovative solution, and long-term planning to protect people and property from future risks. Thank you, everyone.